Hi friends, welcome to AT Tutors. Today we are going to discuss about the system. What is system? According to this definition, the system is a meaningful interconnection between physical devices and components. The physical devices are maybe output devices or input devices and components are in general. In generally, what is system? If we to understand in general, the system is which process the input which we give and it gives the output. For example, here we give the signal x of t. The system will process and it gives y of t. So here we have, if you see, y of t is equals to t of x of t. The system will not give direct output. By transferring the input, it will give the output. So this is the transfer. What is transfer? Transfer function. Output by input is the transfer function. So if we pass the signal x of t through the system, then it gives t of x of t, which is y of t. In discrete, if we see x of n, if we give to the system, it processes and it gives the y of n. Here y of t is equals to, if we take the system as h of n, if we assume the system is h of n, then the y of t is equals to x of t convolution h of t. This convolution is a tool. Convolution is a tool to give the output of the system by the input. Later, when we discuss about the convolution theorems and the properties, we will discuss about this convolution. So what are the types of systems or properties of system? We have linearity, linearity, time invariant or time variant, causality or non-causality, and anti-causality, static and dynamic stability. These are the properties of system or types of system. So today we will discuss about the linearity system. When this system is called linear system, so we will see that if a system is said to be linear if it satisfies the principle of superposition and homogeneity property. This homogeneity property is nothing but scaling property. What is superposition and homogeneity property? If we see here, this is linear system. To satisfy the system is linear, we will go through that. In continuous time signal, if we take x1 of t is passing through the system, we get y1 of t. If x2 of t passing through the system, we will get y2 of t, right? So if we add these two with x1 of t, x2 of t and pass through the system, we will get sum of the two outputs, y1 of t plus y2 of t. If this happens and if it follows scaling property also, so here I done with scaling and superposition principle. I scaled with a x1 of t passed through the system, I got a y1 of t, which is also we can write a x1 of t. So here another, let us assume this to prove b x2 of t passed through the system, I got b y2 of t. This can also written b x2 of t, t of b x2 of t. So I sum this a x1 of t plus b x2 of t pass through the system, I got a y1 of t plus b y2 of t. Okay, I I I assume this output as y3 of t, and if I take y dash 3 of t is equals to a y1 of t plus b y2 of t. If you observe here, this system got a y1 of t and this system got b y2 of t. Individual responses. If we sum the individual responses and if we compare with the both combined response, if they both are equal, then the system is linear system. If we go through one example, we can understand easily. So they will give question like output of the system they will give, and they ask to check whether the system is linear or not linear system. So they gave y of n is equals to n x of n. So what we need to prove this system is linear or non-linear system? We need two inputs. Then if we do sum of the inputs and pass through the system, we will get one response, and individual response we will sum the individual response, then we will compare whether they both are equal or not. If they are equal, the system is linear system, other or else the system is non-linear system. So let us consider x1 of t, sorry, this is discrete, so x1 of n is passed through the system. We got y1 of n, which is nothing but t of x of n, x1 of n, x2 of n is the system, y2 of n equals to t of x2 of n. These are the individual responses of x1 of n and x2 of n. So we apply the scaling factor also here, a and b. If we give inputs a for x1 of n and b for x2 of n, so we will take y3 of n, which is sum of these two responses, y1 1 of n and plus y2 of n. So what is y1 of n? So here is the very important, what is tax1 of n? We should compare with the output response they gave, n x of n. We pass this system, we are getting, if we pass this signal, we are getting the output response like this. So here we gave x1 of n signal, so we will get n into x1 of n, and here n into x2 of n. So what is y3 of n? y1 of n. So here scaling property a and b. So y1 of n is nothing but a into n x1 of n plus b into n y x2 of n. This is one, let us consider. Then we should combine these two and we should pass through the system, then we will get one response. Okay, so let us combine first a x1 of n plus b x2 of n, and we pass through the system. What output we will get? We should compare with the output response, and we should write n into x. What are the x here? A x1 of n plus b x2 of n. So this is 2. Compare 1 and 2. Are they equal? Yes, they are equal. So 1 is equals to 2. Then the system is linear system. So okay, this is today's concept. If you like this video, like, share, comment and subscribe to AT Tutors. Thank you.